Rubber belt. Rubber belt are made of layer of fabric imprinted with rubber compositions and have a thin layer of rubber on faces. These belts are very flexible but are quickly destroyed if allowed to come into contact with heat or oil or grease. One of the principal advantages of these belts is that they may be easily made endless. These belts are found suitable for sawmills, paper mills, where they are exposed to moisture. Balata belts. The belts are similar to rubber belt except that balata gum is used in place of rubber. These belts are acid proof and waterproof and it's not affected by animal oils or alkalis. This balata belt should not be at temperature above 40 degrees Celsius. Because this temperature the balata begins to soften and become sticky. The strength of balata belts is 20% of higher than rubber belts. Types of flat belt drives. Open belt drives. The open belt drive as shown is used with shaft arranged parallel and rotating in the same direction. In the case driver A pulls belt from one side, that is lower side, and it delivers it to the other side, that is upper side. Thus the tension in the lower side belt will be more than the upper side of the belt. So lower side belt because of more tension is tight side as shown. Crossed and twisted belt drive. The crossed or twisted belt drive is used with shaft arranged parallel and rotating in opposite direction. In this case, the driver pulls the belt from one side and delivers it to other side. Thus the tension in the belt will be more than that in the belt LM. The belt RQ because of more tension is known as tight side, whereas belt LM because of less tension is known as slack side as shown in figure. Little consideration will show that a point where the belt crosses it rubs against each other and there will be excessive wear and tear. In order to avoid this, the shaft should be placed at a maximum distance of 20 B, where B is the width of the belt and the speed of the B is 15 meter per second. Quarter turn belt drive. The quarter turn belt drive is also known as the right angle belt drive as shown. Is used with the shaft arranged at right angles and rotating one definite direction. In order to prevent belt from leaving the pulley, the width of the face of the pulley should be greater or equal to 1.4 B. B is the width of the belt. In case of pulleys cannot be arranged as shown, when the reversible motion is desired, the quarter turn belt drive with guide pulley may be used. This is a diagram for quarter turn belt drive. Belt drive with idler pulleys. A belt drive with an idler pulley as shown is used shaft arranged parallel and when an open belt drive cannot be used due to small angle of contact and a smaller pulley. This type of drive is provided to obtain high velocity ratio and when the required belt tension cannot be achieved more. So common belt drive. Common belt drive is used. Power is transmitted from one shaft to another shaft through number of pulleys. That is common belt drive. Then stepped or cone pulley drive. A stepped or cone pulley drive is used for changing the speed of the driven shaft with the main or driving shaft runs at constant speed. This is accomplished by shifting the belt from one part of the steps to another. Flat and loose pulley drive. A fast and loose pulley drive as shown. used when the driven or machine shaft is to be started or stopped whenever desired without interfering with the driving shaft. A pulley which is keyed to the machine shaft is called fast pulley and runs at the same speed as that of machine shaft. A loose pulley runs freely over the machine shaft and is capable of transmitting any power. When a driven shaft is required to be stopped, the belt is pushed onto the loose pulley by means of sliding bar having the belt forks. Velocity ratio of belt drive. This is the ratio between velocities of the driver and the follower or driven. D diameter of the driver due to diameter of the follower and speed of the driver in RPM and into the speed of the follower in RPM. The length of the belt that passes over the driver in 1 minute, that is equal to pi d1 n1. Similarly, length of the belt that passes over the follower in 1 minute, that is pi d2 l2. Since the length of the belt that passes over the driver in 1 minute is equal to length of belt that passes over the follower in 1 minute. Therefore, pi d1 n1 is equal to pi d2 n2. So, velocity ratio is equal to n2 by n1 is equal to d1 by d2. Velocity ratio of compound belt drive. So, d1 diameter of pulley 1, speed of the pulley 1 in RPM, d2, d3, d4, n2, n3, n4. Corresponding values of pulley 2, 3, 4. Another velocity ratio of pulley 1 and 2. So, n2 by n1 is equal to d1 by d2. Velocity ratio of pulley 3 and 4. n4 by n3 is equal to d3 by d4. So, multiplying all, so n2 by n1 into n4 by n3 is equal to d1 by d2 into d3 by d4. We can simply write n4 by n1 is equal to d1 into d3 by d2 into d4. So, n2 is equal to n3 being key to the same shaft. So, we can cancel each other. A little consideration will show that if there are 6 pulley, then n6 by n1 is equal to d1, d3, d5, d2, d4, d6. Speed of last driven, speed of first driver. Then product of diameters of drivers, product of diameters of drivens. This is the ratio should be followed. Then slip of belt. The motion of belt and shaft assuming a firm frictional grip between the belts and the shaft, but sometimes the frictional grip between the insufficient. This may cause some forward motion of driver without carrying the belt with it. This may cause some forward motion of the belt without carrying the driven pulley with it. This is called slip of the belt and is generally expressed as a percentage. So, slip between the driver and the belt. So, as 2% is the slip between the belt and the follower. So, pi d1 by 60 into s1 by 100. So, finally, the thickness of the belt is considered. So, n2 by n1 is equal to d1 plus 1 divided by d2 plus 1 into 1 minus s by 100.